Our project is to develop a prototype of a self-service customer provisioning system hosted on Amazon Web Services. The team consists of myself, Kevin Cranmer, Stephen Garverick, Daniel Hill, Rohan Uponi, and Scott Weston. Our sponsor is Scientific Technologies Corporation, a company based in downtown Phoenix that develops digital solutions in the field of public health. Our instructor for this capstone course is Ming Zhao. The motivation for this project arose from the fact that STC is currently responsible for manually setting up and managing the account information of every single user account for all of their customers. Not only does STC have a lot of customers, but many of these customers are large retailers which may have hundreds of user accounts to create and manage. Setting up these accounts is an extremely time-consuming process which takes STC's time away from more important tasks. The solution to this problem is the development of a self-service customer provisioning system which would allow administrators for STC's customers to be responsible for setting up and managing their own user accounts. These administrators will be able to view a list of all their users, create new user accounts, disable accounts, and reset account passwords. The system supports a tiered hierarchy of users, with customer admins having the ability to manage only the user accounts associated with their company, and an STC admin having the ability to manage all of the user accounts under any of their customers. This will distribute the workload away from STC, allowing the company to run more efficiently and providing their customers with a more personalized point of contact for their user accounts. Hosting the application on AWS also provides STC with a management environment that they can leverage to provide useful metrics and statistics regarding their customers.
So the functional requirements for our project were that the STC administrator can see all of the users, that the customer administrators can only see their associated users, as in people from their organization, and end users cannot access the dashboard because they're not administrators. So the dashboard comes with 4 main features. One, that you can search through the user lists, you can deactivate users, reset their passwords, and then create new users or sub-admins. So non-functional requirements are that the UI should be developed with Angular, it should be resizable and intuitive, that the API gateway should be very secure with token verification, and that there should be functional Cognito user pools that are accessible to STC at the back end, and that account recovery tools work with proper verification. The whole site's secure, because that is the goal of this site. And that it follows the architecture over to the right of those 4 main components all interacting in those key ways. So the first use case is that STC already has an admin and users, and they want to create another administrator. So they create them, and then that administrator can then create their users. Blue administrator can only see blue users. Orange administrator can only see orange users, but STC can see everybody. Second use case, user interacts with customer admin. So a user comes to Walmart and wants to change their password. Walmart talks to STC, says, I want to change my user's password. STC says you can do that with our new tool. Say, cool, thanks. So that saves STC time because they don't manually type it in, and Walmart can just manage their own users. They go in, type in NA for narco, reset the password, and they're done.
Hi, my name is Rohan Uponi, and I will be discussing the technologies involved in building this application. Our front end was built primarily through TypeScript, which is a language that transpiles down to JavaScript and was used as the primary coding language for the front end. This was used in conjunction with 2 main JavaScript frameworks, Angular and Node.js. They both serve a sort of server-client architecture, where Angular would be capable of accessing numerous users' data and be capable of passing this down to Node.js, which would act as the server and make all the APIs and receive the callbacks in order to pass it back up to the users. AWS S3 buckets is the primary technology that we used for storing and hosting the static website in order to run the application. Mainly due to its website hosting configuration, we're capable of hosting our front end with a highly scalable input-output model. Our backend is composed of AWS's API gateway, Lambda functions, and Cognito, and these were all used stressing the concept of scalability. So the API gateway would serve as a scalable endpoint that could be accessed from the front end and would essentially tie the front and back ends together. These gateways would call on Lambda functions that would provide the logical framework for accessing all of this data and be capable of manipulating a database from Cognito. Cognito finally would provide some API calls for manipulating and controlling a database that would host all of the users' data in separate user pools, and would also provide secure authentication for users in the case of logins. So a sort of top-down review of this is the front end, in which case a user would attempt maybe to set up or log into their account, and this interaction would be registered and sent down through HTTP requests made to the API. And targeting these endpoints, those requests would be parameterized and any sort of necessary data would be passed down to the Lambda functions. These Lambda functions would finally process all of this data and make any sort of changes to the AWS Cognito database, whether to register a new user, delete a user, or even just authenticate and log in a user. And finally, AWS's Cognito will provide all the storage of the users in order to log the login information and basically all of the data that would be used by the users. Now Scott will take you through the next point, which would be covering mostly the roles on how each of us focused on these different technologies.
Scott Weston, and I'll be going over the roles and the timeline real quick for our project. After this section, Kevin will run through a demo of the project, and you'll be able to see where everyone's roles line up with respect to the final product. So in the general sense, everyone had essentially two roles. At the beginning, there was a research phase, and everyone assumed the role of researcher because we were all split by AWS resources into different teams. We all researched our various resources, becoming experts in them, so code development could be modularized and productive. And so the second role naturally was one of a developer, as we took our research and implemented it in real time. So there were three basic resources. I'll go through the individual contributions and roles really quick. We already elaborated on them in our summary report, so I'll go through it real quick. So we had the front end, which was Daniel and Matthew. They had the front end user interface with Angular 6.x, whichever version that is. Daniel developed a searchable dashboard and new user form. Matthew developed the login and password pages. There's the API gateway team and Lambda team. They developed the mapping interfaces for which data could be exchanged between Cognito services in the front end. That's Kevin and Rohan. Kevin handled communication with data passed in and worked with the Cognito API. Rohan created endpoints and mapping templates. Then there's Cognito, which is what I'm on. So I did research into the overall topology of the Cognito resources being used by the team, and I worked with the API gateway team to implement critical functions in real time. Steven is also on the team. He did research into Cognito resources and is doing research into tokens for the next phase, which will be the big technology we'll be using in the upcoming weeks. So I'll go through the timeline real quick. Here's just the class timeline and assignments. It's the same as our project proposal. One or two small things changed. As is our current project timeline and progress. So we completed the research phase. As far as progression goes, each team thoroughly researched their resource. In progress is the alpha version, which is a purely functional prototype. We just need to demonstrate the proof of concept. It doesn't have to look pretty. That's what for the later versions and milestones are for. So you can see in February of next semester, we're hoping to get a final draft, get feedback from STC, revise it based off that feedback, add maybe extended functionalities in March, and have a final version by May. So here's just an in-depth look at the alpha version timeline, which is what we're working on now. You can see at the bottom what we've completed thus far progression-wise. We have a functional front end, API gateway integration. We can authenticate temporary and non-temporary users. And so if you look at the timeline, basically we're hoping to complete all base functionality except authorizers in the API gateway by next week, and then use winter break in the first couple weeks of next semester to implement tokens for authorization and complete the alpha version by the end of January. And now here's Kevin.
I'll be going over some of the project deliverables that we have, as well as the use case that Dan has been talking about earlier in the video. So right away, this is the front end that Dan and Matt have been working on. You see we have a customer list, and we can search for customers within the list, and then reset password and deactivate will be implemented later. We have the functions, we just need the endpoint and to hook them up. So the use case Dan was talking about with this STC admin creating a customer admin, they'll come down here, create a new customer, give it the name, username, birthday. Birthday's got this cool little calendar that Dan hooked up, and email. So I'm going to hit submit here. It'll tell us it was successful. Then I can go over to my email. It'll send us an email with our username as well as the temporary password. So I'm going to copy that over. Oops, I copied the period too. Grab that, go over to the Lambda function. So this is the authenticate user function. We haven't hooked up the front end with the back end yet because we need to create the API endpoints. We plan to do that after finals. So when I put in the correct password here, the temporary password, hit save, that's a test event. So now I hit test. It'll tell the front end, it'll return a response telling the front end that you have to go to a new page to force them to add a new password, which would then go to another Lambda function where it changes their password. So here's what the Lambda functions look like. You import the Cognito API SDK thing. You set up the parameters. You set up the Cognito user, and then you can call the appropriate method and give it some like callback functions. So new password required is the case for us. So that would be the SCC admin creating a customer admin and then them having to go and update their password from the temporary password. Strengths and weaknesses of the way that we are doing it. We are trying to keep everything in the back end in Lambda and API gateway. So that means we'll have more security because we can get the user data within the back end and only give the user data pertaining to their own organization. So someone in Walmart won't get data from someone in Albertsons. So that's good for security. For development purposes, it has some weaknesses, as in a lot of the libraries are meant for the front end. So you'll see normally on new password required, you call this function to complete new password with a new password, because you can pause it in the front end, but there's no way to like pause an API request. So we actually have to separate it into two different API requests. So that's fine. We just have to be a little bit more creative with our development, and that's the only weakness. That's all for me. I think Steven is up next, and he'll talk about the lessons learned and whatnot.
So I'm Steven Garberg. I'm going to be talking about the lessons we learned. I'm going to touch a little more on feature plans, and then I'm going to wrap this video up. So we gained a lot of experience with cloud management in AWS, which is very valuable these days. We learned a lot about project organization, how important it is to do that, plan ahead and coordinate before we actually go out and execute. That became more and more apparent. And we got experience in the agile methodology, which is very possible. We had 6 people who learned to communicate very well together. It seemed like every week we actually had to tweak our plans just a little bit. So for our future plans, we plan to finish our API gateways and connect the front end to the back end in December. In January, we're going to implement the tokens and complete our alpha version. And so at that point, we'll actually have all our previously discussed functionality done. So we were thinking in February, we'll discuss adding more functionality with our extra time we have left. In February, we're going to be revising what we have, and then in May, we should have our final version complete. So in conclusion, I think we got a very good jump on this project. We learned a lot of lessons, and moving forward, I'm excited to see what we're going to do with the added functionality and what the final project is going to look like. And we would like to thank STC for providing us with this opportunity and the means to get this done. Thank you very much.